testing a claim about a mean for small sample. So we have our example. In one part of the test developed by a psychologist, the test subject is asked to form a word by unscrambling the letters CIIATTTSSS in 15 randomly selected person. The mean time to unscramble the letters is 52.40 seconds, with a standard deviation of 20.12 seconds. At the alpha 0.05 level of significance, test the claim that the mean time is equal to 60 seconds. Now, the first thing to do in solving problems is to write all the given data based from the problem. So when we read back this problem, we have here in 15 randomly selected person. So that will be our n which is equivalent to 15. The mean time to unscramble the letters is 52.40. So that will be our sample mean, which is equivalent to 52.40. So the mean time is 52.40 seconds with a standard deviation of 20.12 seconds. So our S here, our standard deviation, is equivalent to 20.12 seconds. At the alpha level of 0.05, so our alpha, okay, we have here our alpha, 0.05, 0.05, level of significance, test the claim that the mean time is equal to 60 seconds. So the sample mean, okay, the population sample mean you have here, which is equivalent to 60 seconds. Now, in doing hypothesis testing, the first thing we have to write here is to, of course, the given data. We have to list down all the given data from the problem, and then our first approach in solving this problem is, particularly for hypothesis testing, is to identify our null hypothesis and then the alternative hypothesis. Okay, so null hypothesis, so this is based on the claim. Test the claim that the mean time is equal to 60 seconds. So that will be our null hypothesis, which is equivalent to 60 seconds. And then the alternative, of course, if this is equal to, then the alternative is not equal to. Not equal to. Okay, so that is our first approach in hypothesis in doing hypothesis testing. You have to write first your alternative and the null hypothesis. Next thing is we have to identify our test statistics. So we have here test statistics. Okay, sorry for this one. We have here test statistics. Uh, for this is testing a claim about a mean for small sample, we will be using t-test. Take note, we have different tests. So for this particular problem, we will be using t-test because this we are testing the claim about a mean. And this is small sample. Take note, for small samples, we consider n is less than 30. That is for small sample. However, if we have big sample or large sample, we make use of say test. So for this particular problem, n here is less than 30, which is 15. So we make use of t-test. So in our formula for t-test, we have here t that is equivalent to. Okay, we have here our sample mean minus the population mean divided by our standard deviation over the square root of n. So when we substitute the formula or the value to our formula, so we have here our t. Okay, our sample mean, that is 52.40, minus the population mean, which is equivalent to 60. We have here 60, divided by our standard deviation, which is 20.12, all over the square root of n, which is 15. When we use our calculator, this is equivalent to, using our calculator, okay, calculator, that is negative 1.463. Okay, 1.463. That is the value of t. So for this t, this is based on our computation. So I will write here t computed value. So t com, I will make my own designation for t here. T com means computed value of t, that is negative 1.463. Okay. This time, we will refer to our graphs for t value based on the table. So we will be using t table. Okay. In order to find t, let's say t tab, I will be using here t tab. Okay. That means t value from the table, t table. So t tab. T com is t value from our computation. Okay. So t tab, so we have to refer to our t table. Now take note, this is we're using here equal, our null hypothesis, we have here equal sign. So this is two-tailed test. If we use equal and non-equals symbol, then that is our two-tailed test. So if we have here two-tailed test, I will draw here, okay, this diagram. Okay, this is our diagram. If that is two-tailed test, then we have to find the critical value. Okay, so this is our mean, 0. And then we have to find our critical value. Take note, this is alpha, which is 0.05. So at an alpha, which is the level of significance equals 0.05, then this is two-tailed because we make use of equal, not equal to. So we have to divide this one into 2. So 0.05 divided by 2, that is 0.025. That is divided into 2. We have this part and then this part. Okay. So we make use of an alpha. Take note, our n is 15. N is equivalent to 15. Thus, our degrees of freedom is equivalent to n minus 1. So that the degrees of freedom equals 15 minus 1 equals 14. So, we have here our degrees of freedom, which is equivalent to 14. So, we will be looking our t value at 14 alpha. I mean degrees freedom of 14. We have this one. And then we have two-tailed. This is our two-tailed. Okay, so 0.05, this is our t, 0.05. So we find the value of 2 point, this one, 2.145. Okay, 0.05, our alpha, this is two-tail. And then we have here degrees of freedom of 14. So we arrive to a critical value of 2.145. 2.145. So we go back to our problem. 2.145. This is now our t tab equals 2.145. So this is 2.145. This one is negative 2.145. This is two-tailed. So the other tail is positive 2.145. The other tail is negative 2.145. Now, from our computed value, that is negative 1.463. So 1.463, 1.463. If this is 0, this is negative 2. So most probably it is located here. This is negative 1.463, 0, negative 2. So negative 1.463. That means our uh, area is located here, which is in this part. Take note. Okay, remember this part. That is our acceptance of null hypothesis, acceptance region. And then this part is rejection region. Rejection. Since this computed value of t is under the acceptance region, therefore our decision, so our decision is to accept our null hypothesis. Okay? So when we accept the null hypothesis, then we will now write our conclusion. Okay, our conclusion here. So we have conclusion. There is not sufficient evidence. We will make right here. There is not sufficient evidence to warrant rejection. Okay, so let me transfer this one. To warrant rejection of the claim of the claim, okay, of the claim that the, let's say that the, we have here mean time is equal to 60 seconds. Okay, so in other words, for this one, there is not sufficient evidence to warrant rejection. That means accept, we accept, not sufficient evidence to warrant rejection. So we should not reject it. That means we accept. So there is no sufficient evidence to reject the claim. That means we accept. So that is our conclusion. There is not sufficient evidence to warrant rejection of the claim that the mean time is equal to 60 seconds. This mean time that is based on the claim that the mean time is equal to 60 seconds. So if you have noticed in doing hypothesis testing, our first step is to write our hypothesis testing, I mean the null hypothesis, and then alternative hypothesis. Next is to identify our test statistics. So for this case, we're doing t-test. And after that, we have our decision. Our decision for this case is to accept our null hypothesis. And lastly, we make our conclusion. Since we decide to accept the null hypothesis, then we conclude here that there is not sufficient evidence to warrant rejection of our claim that the mean time is equal to 60 seconds. Another example, we have the Carolina Tobacco Company advertises that its best-selling cigarettes contain at most 40 milligrams of nicotine. But Consumer Advocate magazine conducts tests of 10 randomly selected cigarettes and finds that the sample mean is 43.3 milligrams and standard deviation is 3.8 milligrams. Other evidence suggests that the distribution of nicotine content is normal distribution. The sample is small because the laboratory work required to extract the nicotine is time-consuming and expensive. It's a serious matter to charge that the company advertising is wrong. So the magazine editor chooses a significance level of alpha 0.01 in testing the companies. So we have here our alpha 0.01 claim that is at most that the claim is at most 40 milligrams. So there's an error for this problem. We have testing the company's claim that the mean, so we have here mean. So we lack the word mean from this part. Okay. So testing the company's claim that the mean is at most 40 milligrams. So that is the claim. The mean is at most 40 milligrams. So, of course, again, when we solve problems like this, we have to write the given data. So, you read back the problem. Consumer Advocate magazine conducts tests of 10 randomly selected cigarettes. So, our N, that is equivalent to 10 for this part. We have also a sample mean. Find the sample mean which is equivalent to 43.3 milligrams. So we have here 43.3 milligrams and the standard deviation which is equivalent to 3.8 milligrams. 3.8 milligrams. And then the alpha level here is 0.01. Okay, 0.01. And then the claim here is that the mean is at most. So we have here at most 40 milligrams. So based from the company's claim, at most 40 milligrams. So that is our population mean. Okay. So if we speak of at most, that means not more than. Not more than. Okay. So at most, so not more than 40 milligrams. So not more than, when we speak of not more than 40 milligrams, then we have here our, of course, our population sample mean, that is not more than, so we have here less than or equal to, less than or equal to 40. Okay, so when we write our null hypothesis, we have our population mean is not, less than or equal to 40. And then our alternative hypothesis, if that is less than or equal to 40, then we have our null hypothesis, alternative hypothesis, that must be greater than 40. If this is less than or equal to 40, then our alternative is greater than 40. So if you have noticed, we're using here less than or equal to or greater than. So this is one-tailed test. One-tailed. From our previous example, we make use of equal to, so that is two-tailed. So this time, this is one-tailed. So after we decide our alternative hypothesis and null hypothesis, we make use of our test statistics again. Since our sample size is small, that is 10, so we make use of t-test. So our t, let's say computed value of t-com, that is t computed value, our formula again, that is sample mean minus the population, sample mean, population of the mean of the population divided by the standard deviation over the square root of n. So substituting the value of our sample mean, that is 43.3. So we have this one. We have 43.3 minus our population mean, which is equivalent to 40, divided by 3.8 as our standard deviation over the square root of n, which is equivalent to 10. So we have our value using our calculator, that is 2.746. Okay, 2.746. Now this is our curve. We have this one. Now take note, this is one tail, so this is our mean. Okay, we have here 0. So this is one tail, that means we have only this one on this side. Okay, so we have our t computed is 2.746. So we will write here the 2.746. 2.746. That is t computed value. Now t table, t tab, that is found in our t table. Take note, we have here an alpha which is equivalent to 0.01. So again, this is one tail. So we will look at the value of our alpha, which is equivalent to 0.01. 0.01 alpha. Okay, one tail. This is one tail. And then take note our degrees of freedom, since that is if n equals 10, then our degrees of freedom, which is equivalent to 10 minus 1, that is equivalent to 9. So this is 9. Okay, and then we have here one tail. One tail. Okay, that is 0.01 alpha level. So the area now is, we have this one. Okay, we have this one. So 2.821. 2.821. Okay, so we have here 2.821. Let me check again. 2.821. Okay, 2.821. So if you have noticed here, 2.821, this on this part. So 2.821. 2.821. Okay. Now, take note our computed value is this one, 2.746. Again, our computed value that is located here. Okay. That is less than the critical value. This is our critical value. Okay. So, this is the acceptance. And then this is our rejection. That means we accept again our null hypothesis. We have this one. Because our computed value of t is located in the acceptance region. So we have to write now our decision, which is to reject our null hypothesis. Reject null hypothesis. So our conclusion, I mean not reject but to accept, sorry for that. So we have here accept. Because our computed value of t is located in the acceptance region, so we accept our null hypothesis. That means in our conclusion, there is not sufficient evidence to warrant rejection. That means we accept to warrant rejection that the claim or of the claim of the claim that the mean, so this is our claim that the mean, so I will write here the mean amount, I will insert here the mean amount of nicotine, to be specific, the mean amount of nicotine is at most 40 milligrams. This means that the amount of nicotine is less than or equal to 40 milligrams. So take note again, first in hypothesis testing, we have our alternative and then null hypothesis. Of course, when we have our null and alternative hypothesis, we will determine if that is one-tailed or two-tailed. So for this case, that is one-tailed. Then next step is to identify our test statistics. So for this one, we make use of t-tests. Okay, and then we have our decision. We accept our null hypothesis. Our decision is based on the given value of, after we compute the value of t, and then we find the t value based from the t table. So this is our basis, t computed and then t tabulated. Okay, so our t tabulated, that will be our critical value. Okay, critical value. 2.821. So from our T computed, this is our T computed 2.7, that is less than 2.821. Therefore, it is found in the acceptance region. Therefore, we accept our null hypothesis. So if we accept our null hypothesis, then we conclude that there is no sufficient evidence to warrant rejection. That means we accept our claim that the mean amount of nicotine is at most 40 milligrams.